Hi guys, welcome back. So in the last video, we focused our energy on how to add or subtract rational expressions that have the same denominator. Of course, we did stuff that was spicier than this. This is like what we did, okay? So remember, to add or subtract rational expressions that have the same denominator, we're going to add or subtract the numerators and then write their sum or difference over the common denominator. So again, at the last video, or at the last meeting, we added and subtracted rational expressions that have the same denominator. Now we're going to focus our energy and add or subtract rational expressions that have the different denominators. Okay, so you don't have to print the notes again. If you were printing them, just write this problem after the last problem. So the directions read: perform the indicated operation, which is code for do whatever that operation states. So we got two rational expressions separated by a subtraction sign, so I guess we are to subtract. So the first thing that we need to do is make sure that the denominators are the same. If it's not, then we got to find the LCD. So in order for us to find the LCD for a set of polynomials, let's go ahead and make sure that each denominator is in factored form. I'm just going to go ahead and show all the factoring below. Okay, for the first denominator, prerequisite step is to watch out for common factors. Let's go ahead and factor out a 6, and when we do, that will leave us with x minus 3. Okay, for the second denominator, for me, let's go ahead and put it in descending order. So we'll put the x term first, which is negative, and 6 is positive. The biggest mistake that students will do, they'll just put 2x, 6, and they'll keep the minus in the middle. But no, you can always rewrite things, but please make sure you don't change their values. 2x is negative whether it's at the beginning or at the end, and 6 is positive, same speech. Okay, now that it's in descending order, let's go ahead, watch out for common factors, and in this case we could factor out a 2, love yourself, and then factor out a negative 2. Okay, I lost the pen. Okay, so let's go ahead, factor out a negative 2. When we factor out a negative 2, that will give us x minus 3. So again, the reason why I factored out a negative 2 is because when you take out common factors, it's always to your advantage is if you start off on a positive note. Okay, who cares if the remaining terms are negative? We want the first term to be positive. That way things will look exactly the same if they're meant to be the same. Okay, so let's go ahead write down let's go ahead and write down our new denominators in factored form. Okay, so we have 8 over its freshly factored denominator of 6 times x minus 3, and then we're gonna subtract from it 14 over the denominator in factored form, which is negative 2 times x minus 3. Okay, so at this point I would ask myself, bam, let's work our magic to find the LCD. But check it out, never forget what you previously mastered. So what I recommend, before you identify the LCD, after you factor the denominators, see if you could reduce either fraction. For the first rational expression, we could reduce by 2. So let's do this. So 6 goes into itself, by 2. 2 goes into 6 3 times and into 8 4 times. Someone asked me, what if I didn't reduce right now? It's okay. If you didn't reduce right now, you'll just reduce a little bit more at the end. Okay, now 14 and 2, let's go ahead, reduce by 2. 2 goes into itself once. Let's go ahead, bring down that negative, and into 14 7 times. Cool. So let's go ahead, write down our freshly reduced rational expressions. So I'm going to go ahead, write this here in hopes of me being able to squeeze in another problem. Okay, so we have 4 over the denominator, which is 3 times x minus 3. We got a minus 7 over negative x minus 3. I don't want to have negatives in the denominator, so remember, when it comes to negative fractions, it doesn't matter where you put the negative, top, bottom, or in the middle. I'm going to go ahead, bring it with the numerator. Okay, so we're pretty much, what I want to say, we're still subtracting a negative fraction. Okay, cool, and that will leave us with x minus 3. Okay, what happens if you leave the negative in the bottom? Nothing. Then you just have to make sure that both your denominators are negative, and I don't have time for that. Okay, so now moment of the hour, let's go ahead, find the LCD. So now that we make sure that each denominator is factored completely, remember, how are we going to handle it? We're going to multiply the different factors using the biggest exponent on each factor. Okay, first I'm going to focus my energy on the integer factors, namely 3. There's only one integer factor, so that's it. I don't have to worry about what's the LCD between 3 and something else. Then we're going to focus on the binomial factors. We got an x minus 3 is recycled elsewhere. Remember, you got to use the biggest exponent, and the biggest exponent in either one is still 1. Okay, and we multiply those factors. You know, reference an earlier video that we did on how to find the LCD or LCM for polynomials. Cool. Even though we have ways to go, I kid you not, if you are able to successfully identify LCD, nothing is stopping you. The rest is just a combination of our previous units, you know, which is multiplying, adding, subtracting, and factoring, and all that good stuff. So our next goal is to write those equivalent expressions in English. Fix it so each denominator looks like the LCD just found. The first denominator already looks like the LCD, so we're good to go. But the second denominator almost looks like the LCD. The second denominator has the binomial of x minus 3, but it's missing the factor of 3, so let's give it to it. So let's multiply top and bottom by 3. Now, although we understand ourselves, the world does not. We want the denominator to read x minus 3 times 3, and this only reads like 3 times 3, and we'll subtract it from x. So what I want to say, you need to put parentheses around the binomial. So before we move forward, I want to ask myself, are the denominators the same? Do they both read 3 times x minus 3? Well, let's see. 3 times x minus 3. All right. 3 times x minus 3. The denominators are the same. Okay, they both read 3 times x minus 3 in a slightly different order, but they're the same. So let's do this. So that means that we now have the green light to subtract. So we are going to subtract the numerators and then write the difference. I'm not going to do that anymore. We are going to subtract the numerators and then write the difference over the common denominator. So we have 4 minus the second numerator, which is negative 7 times 3. Let's just show off our math. Will give us negative 21. And then we're going to write that difference over the common denominator, which is 3 times x minus 3. Alright, to finish it off, when we simplify the numerator, 4 minus negative 21 will give us 25. And that's all over the common denominator. So the question that I'm going to ask myself is the same one when it comes to fractions or rational expressions. Is this bad boy reduced? And the answer is yes, because there's nothing I can cross cancel the 25 with. Okay guys, so I said we were gonna do 3 problems. This was our first problem, so we have 2 more. Problem B, we have 30 minus 4x over x squared minus 9. Let's go ahead, add to it 7 over x plus 3. Fantastic. Okay, so again, pause and rewind as many times as needed. Okay, so first things first. So I'm going to ask myself, are the denominators the same? Of course not. Okay, that's how we are in this video. Okay, so because the denominators are not the same, our first goal is to find the LCD. In order to find the LCD for a set of polynomials, we need to make sure that each polynomial is in factored form. I'm cool with the second denominator because there's nothing to factor, but the first denominator we can factor, so we have difference of squares. If you have trouble seeing it, then do the mold. If you don't need it, then I don't need it. X squared is the perfect square because it's the square of x. 9 is a perfect square because it's the square of 3. So this should factor to x plus 3 times x minus 3. Okay, let's go ahead and write down our new problem. So we have 30 minus 4x over its freshly factored denominator of x plus 3 times x minus 3. And then we're going to add to it the second fraction, which was already perfect. Okay, I said perfect because the denominator is already factored. Someone asked me, hey, Mr. Oh, my name, I gotta stop saying my name. The numerator is not in descending order. Do we have to? No, I mean, you can if you want, but it's not vital. It's more for the denominators. They have to be in descending order. Now the question is, what is the LCD? So let's go ahead multiply the different factors using the biggest exponent on each factor. We don't have integer factors or variable factors. All we have are binomial factors. So let's do this. The first binomial that we see is the x plus 3 is happening somewhere else, but either way the biggest exponent on it is still 1. So let's put that in our multiplication list. Another binomial that I see is the x minus 3 is not happening anywhere, so that is the biggest exponent. Okay, what do we do with all these different factors? We multiply them. Okay, and I said it once and I'll say it again. For me, when it comes to adding and subtracting rational expressions, the toughest part is to successfully identify the LCD. If we can't do that, then this is not going to happen for us. So we need to if you skipped that earlier video, please go back and watch it and then watch this video again. Cool. Now that we found the LCD, let's go ahead write those equivalent fractions. So in English, fix it so each denominator looks like the LCD just found. The first denominator is the winner. I'll put a smiley face, okay, just for you guys. I don't do this in class. The second denominator is not quite a winner, but we can make it. The second denominator has the x plus 3, but it's missing the factor of x minus 3. So let's do it. Let's multiply top and bottom by x minus 3. And remember, we always need to have good notation. So we have to wrap up the x minus 3 along with the original denominator. Now the denominator will read x plus 3 times x minus 3. To move forward, I'm going to ask myself, are the denominators the same? Well, they both read x plus 3 times x minus 3. Okay, I'm going to put a smiley face just to like to remind me that I checked it, that this matches the LCD. Thanks to our hard work, now that the denominators are the same, we have green light to proceed. So now I'm like, okay, how do we add two rational expressions that have the same denominator? Oh, we got this. We're going to add the numerators and then write the sum over the common denominator. So let's do this. Yeah, you can't see yellow. Okay, remind me not to use that again. Okay, so the first numerator reads 30 minus 4x, and then the operation is plus. So we are gonna add to it the second numerator, which should read 7 times x minus 3. And then we're gonna write that sum over the common denominator of x plus 3 times x minus 3. Okay, fantastic. So now let's take our time and simplify the numerator and then ask ourselves, is the fraction reduced? When we just clear those grouping symbols by distributing the 7, product of 7 and x is 7x, product of 7 and 3 negative is negative 21. And we're going to write that sum over the common denominator. Some people ask, do we have to write down the denominator at each step? Yeah, you sure do. Some people, after we attack the next section, by accident they try to wipe out the fractions, and I'm like, no, my friends, you can only wipe out the fractions if you have an equation, because you're multiplying both sides by something. This is not an equation. There's no equal sign. Okay, so you don't have like a both sides thing. Okay, so please don't make up your own math. Okay, moving forward. Okay, when we combine like terms, when we combine the variable terms, negative 4x plus 7x will give us 3x. And when we combine the constants, 30 minus 21 will give us 9. So at this point, it's like, oh, we got this. I could see the end and the end of today's class. Okay, so the question that I will always ask myself, is it reduced? You don't have to write it on paper, but if you've been following me, if you're in my class, no one follows me, only my students do. Well, at least I would like to think that they actually look at my videos. Okay. So what I want to ask myself is this: is it reduced? And I put it on paper. Okay, I don't know, so I'm gonna assume that it's not until I realize that it is. So let's go ahead and factor the numerator if possible, and if things cancel, cool, and if things don't, then it was already reduced. Looking at the numerator, 3x and 9 have a common factor of 3, so let's go ahead factor it out, and that will leave us with 3 times x plus 3. Let's bring down the rest of the problem. Okay, So at this point, we realized that the fraction was actually not reduced because we can cancel out a factor of x plus 3. And when we do, that will leave us with, I'm out of space, with 3 over x minus 3. Fantastic. Okay guys, so let's go ahead finish our third and final problem. So we are asked to subtract these two rational expressions. The question is, are the denominators the same? And as you can see, the answer is no. So our first goal is to find the LCD. But in order to find the LCD for these polynomials, our first goal is to make sure like all the denominators are factored completely. So let's go ahead, do that, show all the work below each denominator. Prerequisite step when it comes to factoring is to watch out for common factors. So we're going to go ahead factor out that 2, and that will leave us with a squared plus 2a plus 1. Cool. We got a trinomial, and you know my question. Trinomial, is the leading coefficient 1? It sure is. Okay, so that means we don't have to use the AC method unless you want to, but I don't want to, so we're not. Let's go ahead, throw down parentheses, and work on getting the product of the first terms. The product of the first term should give us a squared, and we're going to use variable times itself. To complete the binomial factors, you want factors of c that add up to b, factors of 1 that add up to 2, and in this case it's going to be 1 in itself where both the 1's are positive. So we check it. Product is 1, sum is 2, so we're good. If you want to use the x game, go for it. It's just I didn't feel like writing it. Under normal circumstances, I wouldn't take the extra step to write exponents for repeated factors, but because we want to find the LCD, I don't want to confuse myself, so I will be using exponents for repeated factors. So we're going to write this as 2 times the square of a plus 1. So one denominator factored completely, one more to go. Second denominator, prerequisite step, watch out for common factors, but there's no common factor to yank out. Binomial minus, we're gonna go ahead, see if we have difference of squares. Because I don't see things, I'm always gonna do the mode. Okay, the mode speaks to me, so I want to know, am I really subtracting two square terms? Well, a square is a perfect square because it's the square of a. 1 is a perfect square because it's the square of 1. So yes, we are subtracting two square terms. So this should factor to a plus 1 times its conjugate, a plus 1 times a minus 1. So if you need to review the video where we factor difference of squares, go for it. Okay, so let's go ahead, rewrite this problem where the denominators are in factored form. Okay, so we have 8a over its freshly factored denominator of 2 times the square of a plus 1. We got a minus, and we're going to subtract from it 3a minus 3, and then the denominator in factored form is a plus 1 times a minus 1. At this point, we can take our time to find the LCD, or we can ask ourselves, are the denominators reduced? The first rational expression, it looks like we could reduce by 2, so let's do this. Why? Because 2 and 8 have a common factor of 2. 2 goes into itself once and into 8 4 times. The question that I get asked, what if I didn't reduce it? It's okay. If you don't want to reduce now, you'll just reduce at the end more. It's no big deal. Okay, so the new rational expression should read 4a times the square of a plus 1. So now I want to know, can I reduce the second rational expression? I want to say right away that the answer is no. At least I can't reduce it without doing some manipulation. For those of you that are overachievers, you're like, oh wait, we can. If you factor out a 3 from the numerator, then things will cancel. Well, that's true. You know, if you do that, yeah, you could reduce. But for me, to tell the truth, with tired eyes, I don't think I would see that. So for me, when I say can I reduce it, I mean like, can I reduce it like right now, not without having to do some fun stuff. So with your permission, we're just gonna leave it as such. If you saw that you can reduce it right now, go for it. Okay, but I told you my speech. So we're just gonna leave the second rational expression as is, or if you want to go on your own, go ahead and reduce it, and then you will confirm that we'll get the same answer. So now, again, unfortunately, the denominators were not the same. This is why we are on the path to find the LCD. our first goal to find the LCD for polynomials is to factor completely. Done. Our second goal is to multiply those different factors using the biggest exponent on each factor. We don't have integer factors or variable factors. All we have are binomial factors. So let's do this. The first binomial factor that we see is the a plus 1. It's recycled elsewhere. So we got to use the biggest exponent, namely 2. So let's go ahead and put 2 factors of a plus 1 in our multiplication list. Another factor that we see is the a minus 1 is not happening elsewhere, so the biggest exponent is still 1. Okay. And I said it before, I think this is our third problem, so this is the third time that I'm going to say it. When it comes to adding and subtracting rational expressions, finding the LCD is like the toughest thing. If we can't do that, then it's not going to happen for us. So let's go ahead and write those equivalent fractions. So in English, fix it so each denominator looks like the LCD just found. The first denominator has both factors of a plus 1. It's just missing the factor of a minus 1. Let's give it to it. So times a minus 1 times a minus 1. Fantastic. So now it reads square of a plus 1 times a minus 1. Let me just put a check mark, okay, to remind me that that's it. The second binomial has one factor of a plus 1, but it needs another factor of a plus 1, so we can have 2. Okay, multiply top and bottom, and remember to have good notation. The numerator will not have to be wrapped up because we have more than one term. So we have the 2 factors of a plus 1. We got the factor of a minus 1. So we have fixed it so each denominator matches the LCD. Thanks to our hard work, now that we are subtracting 2 rational expressions that have the same denominator, let's go ahead, subtract the numerators, and write the difference over the common denominator. So we're gonna, I said I wasn't gonna do this, but I lied, okay? We're gonna subtract the numerators and then write the difference over the common denominator. So let's do this. So the first numerator reads a minus 1 times 4a. To make this aesthetically pleasing, we're gonna put the 4a first. The operation is minus, and we're gonna subtract from it this product, okay? Subtract from it 3a minus 3 times a plus 1, okay? And we're going to write that difference over the common denominator, written however you like. I don't want to confuse myself, so if I took the time to explicitly write LCD equals, I'm going to write the common denominator in the format that form that I defined it. So I'm going to put the square of a plus 1 and then a minus 1. Don't forget to write this down at each step, even if you have to write it like 50 times. Well, it's not 50, but you know what I mean. Okay, let's take our time, clean up that numerator. When we distribute the 4a times a will give us 4a squared. 4a times negative 1 will give us negative 4a. I'm gonna take a pause on the minus. I'm gonna just keep it there. I'm gonna go ahead, find the product of the binomials, and then we'll distribute at the end. Product of the first terms will give you 3a squared. Product of the outer terms will give you 3a. Product of the inner terms will give you minus 3a, and product of the last terms, where am I, gives us negative 3. Fantastic. And that's all over square of a plus 1 times a minus 1. Don't worry guys, we're almost done. Okay, let's continue to clean up the numerator. So we have 4a squared minus 4a. When we combine the like terms, 3a minus itself will give us 0, or they'll cancel out. Let's go ahead, take care of the subtraction sign by adding the opposite, distributing the negative, however you want to digest it. When we add the opposite of a positive term is a negative term. Opposite of a negative term is a positive term. And that's all over, you guessed it, that common denominator. I know the longest denominator is the one that we have to write over and over again. It happens. Let's take our time and combine those like terms. When we combine the squared terms, 4a squared minus 3a squared will give us 1a squared, or just a squared. When we combine, there's only one a term, so minus 4a. We have one constant term, and that's all over square of a plus 1 times a minus 1. Fantastic. So the question of the hour, is this bad boy reduced? I have no idea, so I'm going to assume that it is until I realize that it's not. Okay, Right now we have factors in the bottom, but we don't have factors in the top. How can we tell if we have factors? We have factors if we have multiplication problem across. So for the numerator, namely the trinomial, so we have a trinomial, the leading coefficient is 1, so we don't have to use the AC method unless you want to. Let's go ahead and throw down those parentheses. So we're going to throw down the parentheses, focus on getting the product of the first terms. The product of the first term should give you a squared, and we're going to use variable times itself. To complete the binomial factors, you want factors of C that add up to B, factors of 3 that add up to -4, and I believe that's 1 and 3, where both 1 and 3 are negative. You can do the X game on the side if you like. Product is 3, sum is -4, so we're good, and that's all over square of a plus 1 times a minus 1. And the question is it reduced? I don't know. We got an a plus 1. There's nothing to cancel it with. We got an a minus 1. Check it out. We could cancel it with something. Okay? So I'm very thankful that we asked ourselves, is it reduced? Because we realized that it's not. I'm out of space. I'm going to do an arrow on the side. In the numerator, we just have the binomial of a minus 3. Parentheses are no longer needed because it's not being multiplied by anything other than 1. And in the denominator, we have the 2 factors of a plus 1. I'm going to ask myself, is it reduced? Well, I already boxed it, so yeah. But I'm like, what if I miss something? We got an a plus 1. There's no a plus 1 to cancel it with. So we're good. Okay, guys, we did it. Gracias.